Hello, this is an introduction to GeoGebra. I'm going to be using the web version of GeoGebra for this demonstration. To get there, go to either one of the sites listed. That will take you to this start page where you get the apps. We'll only be looking at the Algebra preset. In the Algebra preset, as you go to it, there is a keyboard at the bottom. We won't use that for this demonstration. And what we have here is a little input on the left, and this left panel is the algebra view. Other applications might call it an object explorer or something of that nature. On the right side, we have our graph, and this can be moved with the mouse and scaled and various other things. So to get started, you can see an input up here, and we want to put a line here. We know that a line is y equals mx plus b, so I'll just type y, an equals sign, an m, a space, an x, and a plus b. When I hit enter, it's going to ask me, do I want sliders for b and m? See, to this point, I haven't defined what b or m are, so I will go ahead and create these sliders. So what I get is a line on here, and you'll see in the algebra pane there's an F colon, so the name of that line is F, which you also see on the line at the top. But I don't really like the line the way it is, so there's a button in the top right corner of the graphics that opens a style bar. This style bar is currently set for the graphics, but we want to change the line. So I select the line, and you notice the icons change for the graphics. Let's change the color to a blue, just by clicking on the blue. Line a little bit thicker by moving the slider. And instead of just the name, I'd really like the name and the value of this line. So we see in small print up here at the top the equation for the value of the line, and we can move that a little bit. It tends to be focused where the line enters the graph on the top or the right. The sliders you can also move. Again, they have a default value of minus, or range of -5 to 5, but you can move them with the mouse. By moving the slider, it changes the values. You see we've got 2.2. You can use the arrow keys to move them one step at a time, or you can use the play button to continually move them. By default, it goes on the back and forth across the range. And you can see how the b value affects the curve, and you can see how the slope value of m affects the curve. So it goes from 5 to -5. And the equation for the curve is changing also. And there's a gear here too. This gear actually opens up another panel here where you've got a little bit more control over the style of this line and the color and various other features. And we can even change the definition of the line if we want to. To turn on the grid, you click off the line or off any object, and we go back to the original icons here, and we see a show or hide the grid. We'll click on that, and we give an options, and again we need to click, and we'll show show the grid. Now GeoGebra will work on the graphics side also, where we can add points by clicking the point. Notice that we have other options for the points. Right now we'll just use the point, and I'll put a point at 2, 1. Notice it named it A, and the definition of that is the pair 2, 1. I can put another point at 4, 3. And it will name it B. The points are named with capital letters. And we want to make a line with these 2 points. To do that, I go up to the next tool and I see a line button. So I make a line through A and B, and that gives me a new line, oddly enough, with the name of G. And the definition again is the line through the points A and B. I want this line to be a different color, so I'm going to make it an orange color. And you can see if I move the points, whoops, you have to get rid of your tool. Have to redefine the color and make it a bit thicker. There. Now I have the cursor button selected, and I can move my points. Notice as I move the points, the point value changes, and the equation for the line also changes. So you see a minus x plus 2y for my G line. And if I put the points right above each other, we get an x equals 2 and y equals 1. We'll go back to the original thing here, and there's some measurement tools within here too. And what we'll want to measure is the slope. So we go to this thing with the angle, and we see down here we have a slope. So slope, and we click the line, and we see the slope of this line is 1. And as we move the point again, go off of it, we see the slope changes. Now I'm going to do the intercept of this line. And to do the intercept, you look at where the intersection of the y-axis and the line is. So we select the line and then select the axis. And you see we've added another point, this point C, which is the y-intersect. So we have the values for our line. We can do a perpendicular line. Let's add another point. Again, I'll go up to the point tool and add it somewhere else. 3, 1. And I want to draw a perpendicular line to my original line. In order to clear things up, I'm going to highlight the original line I had here with the tool and just blank that one out by clicking on the yellow on the circle beside its definition. Now go back to the perpendicular line tool, select the line and the point, and I get a new line of a different color. And if I go back to my point tool, you can see I can move the point and it stays perpendicular to the original line. I can also select the line, get the slope of that line. We see that it's M2 and its slope is -1 right now. Now I'd really like to show the product of these two slopes. To do that, I go over to the input bar and I type in M underbar 1 and then use the right arrow key to get out of the subscript, a space, and an M underbar 2. Now when I hit enter, I get a new value. It calls it A, and it's -1. It's not plotted over here anywhere because it's just a number, and we can't graph a number. So what I do is click the ABC tool and go to the text and click on the screen somewhere, and I go ahead and type in click the latex formula M underbar 1 space M underbar 2 space equals, and then click the advanced down here, and there's the circle with the 5 dots on it, which is the symbol for GeoGebra, and we can click on that and we get to select what we want, and we want A. So we have A, and I added a space, and if I click OK, now we have our equation. We see it's M1 times M2, and its value is -1. So we can move these points around see that even though the two slopes change, the product of the two slopes remains at -1 unless we have a vertical line or a horizontal line where one of the slopes is undefined. Okay, we'll go on to polygons. To do that, we'll go ahead and delete everything we've got here just by selecting it and hitting delete. So anything what was there was deleted. To make a triangle, just click on the polygon here and select points, and when you're done, select the first point again. So we have a triangle, and we see we can go to the measurement tool again, or measurement tools, and select the angle. And then if I click on the triangle, the 3 angles will be shown. Angles are in by default by Greek letters, so we've got alpha, beta, and gamma. And once again, you can see that as we move these points around, the angles will change accordingly. Now what we'd really like to check out is the sum of these angles. So we'll go back to the input bar, and let's bring up the typewriter now so we can go to the Greek letters, and we'll type alpha, go to numbers, plus, back to Greek letters, it's kind of beta, to numbers, plus, Greek letters are gamma, and then hit the return key. So we have a new value, delta equals 180 degrees, and we can add our text again. This time I'll just do it in sum of angles equals, once again, bring up the advanced, click on the GeoGebra, and we notice we're looking for a delta. So we find delta here and click on it. So our sum of our angles is 180 degrees. We can modify this. Again, let's make the text larger. Make it large. Change the color of the background to white. There. Sometimes the number disappears. I don't know what's going on there. So as we move these points around, we can see that the sum of the angles never changes. However we put these. So that's a quick introduction to the graphics and the polygons. We'll delete these in the same way we've deleted other stuff. Select and delete. Now we want to look at equations. So to do an equation, we can just type it in the input field, and I'm going to pick x squared. Use my right arrow key to get down, plus y squared, caret squared, and I'm going to say that's less than 4. So I'm going to plot the equation x squared plus y squared less than 4, which we see is a circle. And again, it's shaded where this inequality is true. We can do another type of relation. Let's do x cubed plus y cubed equals 8. And we see we get a line. And again, we can select the line and show its value, name, and value. So it's x cubed plus y cubed equals 8. When we have a curve on here, we can add a point to the curve. So we have a new point on the curve, and we'll show its name and value. And when we move the point, it actually moves along the curve. So you can pick points along the curve in this manner. GeoGebra also has some calculus capabilities for advanced stuff. And instead of entering an equation like we did before, we enter a name, f, and we have parentheses with an x on it. Then we'll set that equal to, say, x squared minus 4. X squared minus 4. And we'll show that by clicking the circle. Let's delete the other things. We can delete them one at a time also. Notice now that we have our equation for our point, our curve showing. Now we'd also like the derivative of this curve. In this case, this is fairly easy. Just do f prime of x, and we get the derivative of this is 2x. And it also plots the derivative. I'd like the derivative to be, again, a different color. So let's select it and make it purple and make it a dashed line so we can see the derivative a little better. Show its name and value. So back here is its name and value. You can also do integrals, but you have to type that out. So you type integral of f. And if we just type integral of f, we get a new curve. Again, that depends upon the function f of x. We can also type integral. Notice you get some helps. Mostly what you'd use is the function and the low value, let's go -2 to 2. Now we get a shaded box on our graph which shows the area under the curve, and we see it's even labeled that this area is defined as A and the area is -10.67 is what the area is. Now we can go back up here to our function and our definition, and let's change it a little bit to x squared -2, and we see that everything else follows right along. Okay, I hope this is enough to get you started with GeoGebra. Try it, play with it. That's the best way to learn what it does. Thank you.